tool which is used to solve the engineering problem. Okay. Then next, second point comes that why FEM is required. Means FEM is the finite element model. Before going to FEM, just to talk about it. Is it any difference between the finite element analysis and the finite element modeling? Okay. Is there any difference between FEM and FEA? No. There is nothing difference between the FEM and FEA. Both are same. So let's we discuss about the why FEM is required. Now a modern mechanical design which involves the complicated shapes is sometimes made up of different materials. So if it is made up of different material, then it is very difficult to solve that problem. So that's why we are using the FEM. Okay. Here the FE is a numerical method for solving the problems of Indian and the mathematical physics for the complex geometry and material loading and the boundary conditions. Here the numerical measurements it includes the mathematical representation, means some equations, formula, etc. And before going to solve the problem, we assume there's some required data and to solve the problem. The final one is the FEA is an approximate method. We get an approximate values. Here we can't get an accurate result. By using FEM, we only get an approximate result. Here, there are some general steps are included in the FEM. While the first one is the discretization of the continuum conditions. Second one is the displacement model. The third one is the element stiffness matrix. Fourth one is assembly of element properties. And fifth one is the boundary conditions. And sixth one is the solution for ion displacement. And the seventh one is the computation of the suspension. Let's discuss about one by one. The first one is the discretization of the continuum condition, where the step involves the dividing the functional structure into smaller regions, which is called as a finite element. Now these elements are connected to each other through the nodes, and the elements and the nodes are numbered after the discretization. The discretization involved means to divide the entire structure into the smaller regions, which are known as the finite elements, and these finite elements are connected to each other through the nodes. The second one comes from the displacement model, where the displacement model is a function which is selected to represent the displacement at any point within the element. There are two types of the model. The first one is the polynomial function, and second one is a trigonometric function. The difference between this polynomial function and trigonometric function, we maximum use the polynomial function because these are prepared for FEA due to its easy of mathematical calculation. And this polynomial which can be used for the first order, we know that it's a linear, and if we are used for the second order, then it's known as a quadratic, and which is used for the third order is known as a cubic. All the order can depend on the shape of the element. Then comes from the angle stiffness matrix, whereby using the minimum P, the equilibrium of the element is determined. Where this minimum P stands for the potential energy. The minimum potential energy states that if the body can be stable, then it will have a minimum potential energy, and this is represented by using the mathematical equation that is the K Q equal to F, where this K stands for the element stiffness matrix for the individual element, the Q stands for the displacement model, and F stands for the load. Then after completion of this, then the next step is to assemble the each and every individual element into entire element. Then the individual elements equations are added by the method of the superposition to obtain a group equation for an entire structure. This is represented by using some mathematical equation, the K Q equal to F. But in this equation, this K stands for the entire, means is a global stiffness matrix for the entire body. The Q is the global displacement factor, and F for the global force factor. Then after this one, we have to apply the some boundary condition, where the appropriate boundary conditions are to be applied to the global equations to obtain some global displacement. And there are two types. The one is the elimination approach,